This is the video for section 1.4, slides 23 through 25. So in this section, we're talking about the limit of f of x as x approaches infinity. So what does this mean? Well, if x is approaching infinity, this means we're looking for the limit of f as x moves increasingly far to the right. If x is approaching infinity, we're moving along the x-axis to the right. Which means that the limit of f as x approaches negative infinity means the limit of f as x moves increasingly far to the left. Not really a difficult thing to visualize. All right, so now what we want to do is we want to think about, well, let's start off with the limit as x approaches infinity of 1 over x. Now, we're going to think about this both graphically and numerically. All right, so first of all, 1 over x. Well, you're going to have to know what 1 over x looks like if you want to think about it graphically. All right, so we can think about it graphically. You may recall that the graph of 1 over x looks like this. So what am I interested in? Well, I'm actually interested in what's happening as this part of the graph continues on. Okay. Well, you may recall, maybe not, all right, that this graph has a horizontal asymptote at y equals 0. So what does that mean? That means as x gets larger and larger and larger, the y value, or 1 over x, actually gets smaller and smaller and smaller. All right, let's think about it a different way. Let's think about it numerically. Numerically, what does that mean? Well, let's take numbers of x that get increasingly large. For instance, let's start with 1. 1 over 1 is 1. What about 10? What is 1 over 10? That's 0.1. What about 100? 1 over 100 is 0.01. 1 over 1,000 is 0.001. 1 over 10,000, 0.0001. We could keep going, making that denominator larger and larger and larger and larger. What's going to happen to 1 over that number is it's going to become smaller and smaller and smaller, but still positive and approaching 0. So what does that mean? The limit as x approaches infinity of 1 over x is 0. We are approaching this horizontal line of y equals 0. All right, what about as x approaches negative infinity? Well, now we're talking about what's happening on the left side of this graph. So once again, x is getting larger and larger and larger in the negative direction. So 1 over negative 1, 1 over negative 10, 1 over negative 100, 1 over negative 1,000. So once again, negative 1, negative 0.1, negative 0.01, negative 0.001, and so on. All the while, every number is negative, but still getting closer to 0. And so once again, we can say that this limit is 0. So overall, what are these questions actually asking about? Well, graphically speaking, they're just asking about the existence of a horizontal asymptote. All right. So now the limit as x approaches infinity of 1 over x is 0 because the value of 1 over x is approaching 0. The limit as x approaches negative infinity of 1 over x is also 0. So now, this sounds kind of weird, but in a limit problem, okay, we always evaluate the function, right? So can you take infinity and substitute it in for x? Well, you get 1 over infinity. Now, I know that that's kind of weird. You can't really do an operation with infinity, but in a limit problem, we will accept 1 over infinity to equal 0 because we know that it means that the limit as x approaches infinity of 1 over x equals 0. In the same way, 1 over negative infinity is also going to equal 0. All right, what about over here? Well, if I am going to substitute infinity in for x here, I'm going to get 1 over infinity squared. But what is infinity squared? Well, infinity squared is, well, it's still just infinity, isn't it? So 1 over infinity, once again, we accept that to equal 0. Same thing down here, 1 over negative infinity squared. Well, negative infinity squared is positive infinity squared. So it's just positive infinity, which means we are still approaching 0. Now, I do want to discuss for a second, okay, the negatives versus positives. What does the fact that these numbers were negative mean? Well, that we're approaching that horizontal asymptote, but from below. In the first example, we were approaching the horizontal asymptote, but from above. So what do you think about both of these? Both of these were positive infinity. So that means that this graph, as we move to the right, must be approaching from above. And this graph, going to the left, must also be approaching from above. So what does that mean about the graph of y equals 1 over x squared? It actually looks like this with a vertical asymptote at x equals 0 and a horizontal asymptote of y equals 0. So once again, 1 over infinity in a limit problem, we accept to equal 0 based upon this discussion. All right, so we're going to use that in order to answer some of these limit questions. Now, the first step in a limit problem is to evaluate. So we're going to substitute infinity in for x. All right, so if I do that, I get 20 times infinity squared minus 3 times infinity divided by 3 times infinity to the 5th minus 4 times infinity squared plus 5. All right, so now this is kind of weird. Infinity squared, well, that's infinity. 20 times infinity is infinity. And I have infinity minus 3 times infinity. Well, that's infinity. Infinity minus infinity, not 0. Okay, now this is important. This one was 20 times infinity squared. This was just 3 times infinity. So are these infinities equal? And the answer is no, they're not equal. So the result of taking infinity minus infinity is actually still infinity. Now, I'm going to say this again in class, but think about this. If I have this infinity, which was an infinity squared, and this infinity, which was just a regular infinity, how much larger is infinity squared than infinity? Well, it's actually infinitely larger, which means that infinity minus infinity is actually still infinity. Okay? Now, don't get confused by that, but just understand that when we're doing these operations with infinity, we can't like zero it out. All right, now, what about this one? Infinity to the 5th minus infinity squared plus 5. Well, once again, this is going to be like infinity minus infinity plus 5. The 5 doesn't really do anything, but once again, we're still going to end up with infinity. So now, what does that mean? That we have an indeterminate form, infinity over infinity. Okay, so just like when we got 0 over 0, we have more work to do. All right, so what is the more work? All right, we are going to find the highest power of x. So what is the highest power of x? I have a 2, a 1, a 5, a 2, and a 0. So I'm going to find the 5. I'm going to take each term in this quotient and divide by x to the 5th. All right, so I have 20x squared over x to the 5th minus 3x over x to the 5th, all divided by 3x to the 5th over x to the 5th minus 4x squared over x to the 5th plus 5 over x to the 5th. And remember, we have not evaluated the limit yet, so the limit as x approaches infinity. All right, so now, what do I get? Well, 20x squared over x to the 5th. What is that? Well, the x's can reduce. I'm left with 20 over x cubed minus 3x over x to the 5th. That's just going to be 3 over x to the 4th divided by, all right, 3x to the 5th over x to the 5th. That is just 3. That's significant. Minus 4x squared over x to the 5th. That's going to be 4 over x cubed plus 5 over x to the 5th. Nothing can reduce there. Now, you might see why we actually did that. Because now when I plug infinity in, I get 20 over infinity cubed. 20 over infinity cubed. Well, that's actually just 20 over infinity. Now, why is that important? Because 20 is a finite value divided by an infinite value. And what did we say on the previous slide? Like 1 over infinity, that's 0. In the same way, any finite value over an infinite value is going to tend to 0 as well. So minus 3 over infinity to the fourth. That's going to be infinity once again. And so I'm going to get 0 minus 0. That is 0. All right. Divided by 3 minus 4 over infinity cubed. That's going to be infinity plus 5 over infinity to the fifth. That's going to be infinity. And so I'm left with 0 minus 0 over 3 minus 0 plus 0. So 0 minus 0, that is 0. 3 minus 0 plus 0, that is also 0. And so I end up with 0 over 3. Well, guess what? 0 over 3 is 0. So the value of this limit is, in fact, 0. Now, the next example, okay? Same idea. We would evaluate initially. We get 7 times infinity squared. That's 7 times infinity minus 9, divided by 4 times infinity plus 3. Of course, 7 times infinity over 4 times infinity, well, is still infinity over infinity. You can't like reduce the infinities or something. All right. So infinity over infinity, once again, indeterminate, telling us that we must do some more work. All right, so what is the more work? Find the highest power, squared. So divide everything by x squared. So 7x squared over x squared minus 9 over x squared divided by 4x over x squared plus 3 over x squared. And don't forget to rewrite the limit as x approaches infinity. All right, so now simplify. All right, limit as x approaches infinity. 7x squared over x squared, that's 7. Minus 9 over x squared, nothing changes there. Divided by 4x over x squared, that's just 4 over x. Plus 3 over x squared, that is 3 over x squared. All right, so now once I reduce, just like in our earlier work, we can reevaluate. So I get 7 minus 9 over infinity. What is 9 over infinity? Well, that's going to be 0. So we're going to have 7 minus 0. Divided by 4 over infinity plus 3 over infinity squared. So 4 over infinity, once again, that's 0. Plus 3 over infinity, that's also 0. So I'm going to end up with 7 over 0. Now, think back to what we've already done. 7 over 0, this is approaching an infinite value, right? Now, it is infinity, but is it positive or negative? Or does it matter? Well, it does matter so that we understand the nature of the graph. Think about this. Limit as x approaches infinity. We are trying to determine what's happening with this graph as we go to the right. So are we going up and to the right, approaching positive infinity? Or are we going down and to the right, approaching negative infinity? So we actually need to think about the value of these zeros. Now, that's kind of weird. What does that mean? Value of zeros. Well, it actually means whether or not they are positive or negative. Remember, this is a limit question, so we're only approaching 0, and whether or not one is larger than the other. Okay, so if I'm plugging in a positive infinity, 4 over infinity, that's a positive number, right? So we're approaching 0 from the right. 3 over infinity, that's also a positive number. So I'm taking a positive number plus a positive number, which means we are always resulting with a positive number. So 7 over 0 from the positives is positive infinity. Therefore, this graph is going up and to the right, not down and to the right. All right, moving on to slide number 25. All right, once again, evaluate each limit without graphing. Now, the first thing we see here on example number 3 here is, well, you've got this square root. So we talked about how to deal with that. All right, first thing that you should do is you should recognize that the square root can be brought outside of the limit to make the problem a little easier. So limit as x approaches negative infinity of x squared over x squared plus 1. All right, so now we forget about the square root for a moment, and then we are going to evaluate the limit. All right, and so I get the square root of in negative infinity squared. So negative infinity squared, well, that's going to be negative infinity squared. That's actually going to be positive infinity. And then I have negative infinity squared plus 1. Of course, that's going to be positive infinity. So I get the square root of positive infinity over positive infinity, which is still going to be infinity over infinity. So we have more work to do. So now I'm not going to go back to the original problem. I'm going to leave the square root on the outside, but now I'm going to divide each thing by the highest power of x, which is 2. So I'm going to take the numerator and take x squared over x squared. And then I'm going to take the denominator and take x squared over x squared plus 1 over x squared. All right, so now let's simplify a little bit. I have the square root of, and then I have the limit as x approaches negative infinity. All right, so now x squared over x squared, that's 1, divided by x squared over x squared, that's 1, plus 1 over x squared, that stays the same. All right, so now if I reevaluate, I have the square root of, well, now if I evaluate, negative infinity squared there. So I have 1 over 1 plus 1 over negative infinity squared is a positive infinity. So that's a positive number. So 1 over infinity, that is approaching 0. So I have the square root of 1 over 1 plus 0. 1 plus 0 is 1. 1 over 1 is 1. So the square root of 1 is 1. So this limit is, in fact, approaching 1. All right, and then the last one, this one is kind of weird. It says the limit as x approaches negative infinity of cosine of x. So if we evaluate, we get cosine of negative infinity. Well, you can't really evaluate negative infinity in a trig function, right? That seems kind of weird. So what we want to do is we want to examine the graph. All right, what is the graph of cosine? All right, so cosine, you should know, starts at its max and continues with its wave like this. That would be towards positive infinity. But what about towards negative infinity? Well, same thing, basically. We continue this wave here, and it continues forever in that direction. So now, the key is, what's happening as we go further and further and further to the left? Well, the fact is nothing different is happening. This thing just keeps going back and forth between -1 and +1, which means that this function is oscillating between two values. Therefore, we would say that this limit does not exist.